Your dashboard shows perfect uptime, but during critical traffic spikes, your customers still face broken checkouts and 503 errors. This calendar shows what that guarantee actually allows. A 99.9% SLA permits up to 8.76 hours of annual downtime. The issue with those 8 hours isn't the length of the allowed outage. The vulnerability lies in how your hosting provider defines being online. Standard hosting contracts rely on network uptime. They run an external ping, and if the server's network interface returns a basic TCP response, the test passes. That ignores application uptime, which tracks the only metric your business cares about, whether WordPress successfully renders and delivers an HTML page to the visitor. The uptime split table illustrates this gap. On the left, the network layer. If the server responds to a ping, the contract is fulfilled. On the right, the application layer. If visitors see a white screen, you lose money and cannot claim compensation. Relying entirely on that top-line percentage creates a false sense of security. You are trading cheaper monthly hosting costs for a complete blind spot regarding application-level failures. To understand why a server passes a network test while failing a customer, we have to look inside the application architecture itself. When a dynamic request comes in, WordPress relies on a PHP worker pool. Think of this as a strict queue of background processes, where each worker handles exactly one uncached request at a time. A standard brochure site survives low worker limits because most visitors receive a saved cached page. The request never even touches the PHP workers. This flowchart, titled Traffic Spike Anatomy, shows what happens with WooCommerce. Cart updates and checkouts cannot be cached. Every single interaction routes directly into the PHP worker pool. Budget shared hosting plans enforce a strict ceiling, typically allocating a fixed limit of only 4 to 8 PHP workers per account. When a flash sale or email blast hits, concurrent visitors saturate that queue instantly, forcing the server to reject the overflow with 503 errors. Meanwhile, the core web server is technically functioning, so it returns a valid HTTP status code. The network ping succeeds. Your checkout process is entirely broken, and sales stop entirely, but your hosting provider's automated monitors log 0 downtime. Putting a dynamic store on an entry-level shared plan forces a specific compromise. You lower your monthly overhead costs, but you invite rapid worker exhaustion during the exact moments your traffic is most valuable. Outside the server wall, your site faces a completely different vulnerability hidden away at the external network level. Most entry-level plans place your business on a shared IP address, binding your network identity to dozens of unknown sites. If one of those neighboring sites sends out a massive spam blast or becomes the target of a DDoS attack, your site is caught in the blast radius. Upstream firewalls will temporarily block the entire IP address to mitigate the attack. Your site becomes completely unreachable, and because the block originates off-server, the SLA covers nothing. Solving both the internal PHP bottleneck and the external shared IP threat requires premium infrastructure designed for isolation. This server cross-section shows CloudLinux CageFS in action. It imposes strict OS-level isolation in a shared hosting environment. Kernel-level boundaries guarantee your account has a dedicated PHP worker pool. Even if a neighboring site spikes, your allocated resources remain entirely untouched. The second requirement for true availability is moving away from shared network routing and securing a dedicated IP address. With a dedicated IP, no neighbor's malicious behavior or DDoS attack can filter your traffic. Your network identity is exclusively yours. Upgrading to OS-level isolation and dedicated routing demands a higher monthly premium. In exchange, you insulate your backend resources and your network reputation, keeping your site online during critical revenue events. Translating these technical trade-offs into a business decision comes down to matching your specific risk profile to the correct infrastructure. This 2x2 hosting uptime matrix charts this out. The vertical axis measures site complexity and dynamic traffic, while the horizontal axis tracks the revenue risk or cost of downtime. In the bottom left, we have the budget brochure segment. If you operate a static, heavily cached portfolio site, accepting the blind spots of a standard shared SLA makes financial sense. Low dynamic traffic means you will rarely trigger application layer failures. The calculus changes in the scaling e-commerce segment. Stores processing 50 to 100 concurrent checkouts must abandon entry-level limits. You need OS-level isolation to prevent neighbor-induced errors from killing active sales. Finally, we reach the high-volume membership segment. Managing over 500 concurrent logged-in users requires absorbing the higher costs of a VPS or dedicated server. That tier gives you the control to manually expand PHP limits and avoid system-wide timeouts. Before signing a long-term contract, set up an external monitor like UptimeRobot alongside internal WordPress query logs. Run them for 30 days to measure your true application uptime. True availability is not a percentage promised on a marketing page. It is achieved by acknowledging the mechanical limits of an SLA and aligning your site's dynamic load with the exact infrastructure built to handle it.